This
Presentation.
conference will now be recorded.
I just started. Hello everyone. I hope everyone is able to see the screen and let's begin. You are able to hear me loud and clear. Yeah, we have covered two container objects. Yeah, in the initial discussion we spoke about what exactly is a list. List is a mutable object. Tuple is an immutable object. We know the difference what is between mutability and immutability. So tuple is read only, that is we cannot change the contents. So once we initialize, that's the end of it. Yeah, there are some advantages with tuple. Performance wise, tuple is a little bit faster when compared to list container. Okay. Right. So why is tuple faster? Because it is read only. So changes are not allowed. That's the reason why tuple is a little bit faster. Okay. Now let's see the third container object. That's a set. Yeah, set has some different things like when compared to a list and a tuple. The first thing is the order of elements what we add to the set, they are not maintained. That is, it cannot remember the order. What is first element? Where is first element? Means we might have added elements when we have created the set. It will not store the elements in the same order. So order of elements is not guaranteed. So when order is not guaranteed and when we are not sure, like set doesn't store the elements like first element, second element, third element, when it does not give us that particular guarantee, yeah, we cannot access the elements using index values as well. So indexing is one which is not available. And the most important thing is set will store elements that are unique. Means it will never store duplicates or repeating elements, or repetition of elements is not allowed as part of the set. Which means if we try to add an element multiple times, it will store only once. If an element is already there as part of the set, we try to add another element, not possible. It's not possible in the sense it doesn't throw any exception or an error, but because the element is already there existing, it doesn't make any major difference because already the element is there, so it's fine. Okay, right. So a group of unique means repetition is not allowed. Heterogeneous, different types, dissimilar data type, collection of elements we can store or hold as part of a set container object. So set is mutable. Yeah, we can add elements, we can remove elements. Yeah, order is not maintained, so index-based access is not allowed. Slicing, slice object and all that is not allowed. Okay. Before we go any further, let's start. Yeah, just trying to start Jupyter Notebook in here. Yeah, let's get it. So some methods, some predefined, some built-in functions related with set. Yeah, we can add an element. Yeah, we can remove an element. Yeah, what is the difference between remove and discard? We'll try to explore that. Okay. Then, yeah. Oh, yeah. Remove, discard, and pop. Yeah, just look at that. Remove and discard takes element that we want to remove from the set. Pop doesn't take any. It randomly removes an element. It removes the last element basically. We'll look at that. Length we know. Yeah, length built-in function which can get the number of elements in the set. Yeah, we can create a copy of the set. Yeah, we'll just look at the difference. Yeah, I not discuss about copy with respect to tuple because we don't make any changes to the tuple there. So once we have created a tuple object, we don't change. Basically, we cannot change. That's the reason why we don't change the contents. So what big deal is it when we copy a tuple into another tuple when we are not making any changes in there, right? Yeah. Yeah, clear is one function which will remove all the elements in the container object. So with set as well, we can use it. Yeah, clear is not available with tuple because we cannot remove elements, right? Yeah, delete is a little bit different. Clear is emptying the contents of the set, and delete is removing the set object itself from memory. Yeah. Okay, we'll see exhaustively all of this. So we just started the Jupyter notebook in here. Yeah, the Jupyter server is running behind the scenes. Let me start or launch a new notebook. I'll just add some cells so that I can have some empty cells so that I can quickly jump over and start working. Okay. I'll zoom in a little bit for everyone's convenience. Right. So set, that's it. That's a set object. You can just check it. Type of S will give us shift enter. It's a set object. Okay. Yeah, it's empty. It's empty. Yeah, you want to create a set. Yeah, we give elements like this. Any number of times you repeat, it will store only one time each element. So I might have repeated many times 1 and 2, but it stores only one time. That's the advantage with a set. Yeah, unique elements. So length of S is going to be 2, but not those 13 elements. 13 times that we have stored 1 and 2, both combined together, it's not going to be. Yeah, we can store heterogeneous. So let's see, explore 10, 10.01, 10.001. Okay. Yeah, let's store as well a string. Yeah, see the difference. Case sensitivity. Case sensitivity. Okay. Yeah. Then we have a true, a boolean value, and a false, a boolean. Okay. Right. Just look at the elements. Yeah. Hello. Case sensitivity. It is not. Hello is a string. Yeah. It is following case sensitivity. Okay. You're starting with H. See, order is not being maintained. Three digits or three decimal places precision comes first. Two decimal places precision comes next. No decimal place precision comes first. I don't know why, how. That's how it internally arranges. So which is first element, which is last element, we cannot guarantee on that. That's the reason why index-based access, if we try to do like, okay, I want to access first element, no, not possible. So set object does not support indexing. Okay, yeah. Case sensitivity is also maintained. Okay, right. So what does that mean? Yeah, that's a list. Yeah, set here. Okay, let's just check this. Yeah, you change the word with even one character. Yeah, a lot of changes in there. Yeah, look at it. Yeah, three different words. It will try to recognize them as. Okay. Yeah, even if you vary or differ with one character, yeah, it will consider it to be each one to be a separate word or a string. Okay. Right. So we are good. So let's see. Yeah, we'll try to create a set here. I want you to closely observe. True, true, false, false. Of course, even though we have stored it multiple times, it will store it only one time. That's fine. So what if I combine some values like 1, true, false, 0. In Python, 1 and true are same. False and 0 are same. Okay. So see what happens. Now why? I told you true and 1 are same. Okay. So I'll show you one thing. Value some variable v equal to 10. So Boolean value of this typecasting function, anything that is non-zero is true. Okay. Right. I can also show you very precisely Boolean converted value of that v which is containing 1 is true. Same variable v if it is containing 0, and if I try to print Boolean converted value of that v which is 0 will be false. So in set notation, set format, when we try to combine 0 and 1 with true and false, any one of them will be stored, but not both of them. Why? I gave you a clear explanation in there. Okay? Right. So that's how basically a set behaves. Right? Yeah. Good. So let's add some elements, remove, discard, and see the difference between remove, discard, and pop in there. Right? Yeah. Okay. Don't worry. Look at this. You will create a simple normal set. We will try to add elements. Okay, set object. Yeah. S dot add of say 3. Okay. Element was not there. That's the reason why the element got added. S dot add of 0. 0 is not there. Now we added, we don't know how it will be arranged internally. Okay. Yeah, don't look at it like it's storing the elements in ascending order or something like that. Don't come to conclusion like that. You never know. Right. So if we already have an element, say suppose 0, 1, 2, 3 we have. So if we try to store one more time an element that already exists as part of the set, here you will not see any major difference in that because duplicates not allowed. Okay. Yeah. So we are good. Yeah, let's explore the remove, discard, and pop. S dot remove of something which is not existing. Okay. So S dot remove of something that is existing. Okay. Yeah, we cannot have multiple times an element. So if the element is found, it will be removed. Otherwise, you'll get a key error. So S dot, okay, S dot discard element that is not there. We don't get an error here, even though that particular element is not there as part of the set. But remove
Government,
did
can
throw
we
an
remove multiple values? Suppose s dot remove. Actually, we remove 0. Instead, we can use 2 or more values at a time.
yeah 1 comma 2. It takes only one argument, not more than one. Okay. So S dot, yeah, S is containing 3 elements. S dot pop, yeah, it removes an element. Yeah, which element? Take it like it's removing the first element. Yeah, remove takes one argument. If you're not supplying that, again an error. So I think we have only 3. The value in there, better supply. Or you can use pop. So S is empty. Length of S is 0. So you got the difference between remove, discard, pop. Remove throws an exception if the element is not found. Discard doesn't throw any exception. Pop removes the first element. Take it like that. Yeah, length we know. Let's see copy. So how do we copy the contents of one set into the other without using copy function or copy method, and one with copy. Okay. So I'm showing you here shallow copy. Shallow copy. Right? Yeah. Right. So what we'll try to do here is we'll create one set with some elements s2 equal to s1. Look at the ID of s1 and ID of s2. Both are same. Means if you make changes to S1, it is as good as you are making changes to S2 and vice versa. So S1 dot add of 10. We have made changes to S1. Yeah, S2 also gets affected.
Can you repeat that S1 dot ID that what is go up?
There's nothing in there. We spoke about this when we spoke about lists.
Okay.
It's a memory reference. As part of memory, S1 and S2 are referring to the same memory location. So you make changes to S1 or S2, it is same. I have added to S1. S2 is also reflecting the same. So if I remove the element from S2, what will happen? We think like we have removed only from S2? No, we have actually removed from that particular memory location which is being referred by both S1 and S2. So it is not two separate individual independent memory locations. It is the same memory location that you are referring to. That's the idea of the memory reference. Now with copy function in Python, it creates two separate individual memory locations. And that's what we refer to as deep copy. So S1, S2 equal to S1 dot copy. Now look at the ID. They're totally different. So you make changes to S1 or S2, I mean the other will never get affected. Okay, let's look in there. You're adding an element to S1. S1 gets appended, but S2 remains unchanged. Removing an element from S2, S2 gets modified, but not S1. So that's the difference between normal copy and deep copy. So normal copy, shallow copy. Using assignment operator we do it. Deep copy, we use the copy function or copy method to do that. Okay, let's be a little bit careful here. Yeah, we'll try to understand what is the difference between clear and delete. Okay, right. Okay, let's just see length of S1, length of S2, we are fine there. Yeah, what S1 is containing, we know. What S2 is containing, we know. If I say S2 dot clear, what happens? The contents of all the elements in the set S2 will be removed. So the length becomes 0. Okay, so S2 still continues to exist, but if I say delete by calling del function S1, what happens? S1 is completely removed from memory. It's not being identified as a valid variable here. Elements are removed, everything is removed, the set object S1 is completely removed from the memory. Yeah, please be careful when you're using that clear and del function. Clear will remove all the elements from the set. It's something like a new set that you have created. It will keep something afresh. Yeah, you can still continue to work with it. You can add elements, but once you have deleted it, yeah, it is something like you have dereferenced it or you have removed it completely out of memory or scope. Yeah, you cannot use it again, right? Yeah. Let's see some set operations. Now set theory. Yeah, our elementary school mathematics, if we can refer to that, we might have seen something like union, difference, intersection, those kind of operations we can perform on the set objects, set container objects. A union function and the pipe symbol both are same. Difference function or difference method and that minus symbol both are same. Intersection, ampersand. Union means what? Combining all the elements, but still maintaining only unique values as part of the set. So we want to include all the elements in all those sets, but we want to make a unique collection of it. We don't want to have repeating elements or repetition of elements. What do you mean by difference? Yeah, difference is something which is available in one set very uniquely, which is not part of the other set. So that's what is difference. Intersection, something which is common. Okay, let's see our Venn diagram. Yeah, we might work with two sets or three sets, it doesn't really matter. Okay, let me put the universal set in there. That's our universal set. Right. Let's consider that to be set A. I'm just going with primary colors in there. Set B. Okay. I'll just try to mark the area. Yeah, this is the intersection area, correct? So if we need to consider, yeah, give names to these sets. Set A and set B. Now A and B you can replace with anything. Customers, products, students, subjects, students, courses, bank, types of accounts and all that. Okay. Yeah, anything. So that is A intersection B area. Okay. Right. Then what is this is elements which are very unique to A when compared to B. That's what is A minus B. Okay. Right. Elements which are very unique to B when compared to A. Universal set A union B. Okay. Right. So if you need to mark these areas like that is A intersection B. No. A minus B. Yeah, this is A intersection B. This is B minus, okay. Yeah, A minus B and B minus A cannot be same. They'll not be equal. Okay. Yeah, with this as understanding, we'll try to work on some examples. I hope you'll be able to understand, interpret. Very simple, very easy. Yeah, we'll use the functions as well as those operators or symbols. Okay. Right. So let's get in. Yeah, going back to Jupyter Notebook. Working with set operation related methods. Union, intersection, difference, etc. Let me just convert that to markdown. I just want to put a heading there. Right. Let me take two sets as one. Yeah, any order. Right. Yeah. As two. some elements. Yeah, intentionally I did not take repeating elements. So S1 union S2. All the elements which are unique in both the sets combined together. Same result. Yeah, the pipe symbol or the union function, yeah, they'll give the same result, right? Yeah. Let's see difference. Difference in the sense, elements which are unique in one set when compared to the other set. So what are those elements which are unique in S1 when compared to S2? 1, 2, 3, correct? Elements which are unique in S2 when compared to S1. 6, 7, 10, correct? Yeah, we can do the same. S1 dot difference of S2. S2 dot difference of S1. So S1 minus S2 and S2 minus S1 are never same. They're never equal. Okay. So minus is the symbol, or you can use difference as the method. So I think we are good with what is that union, the pipe symbol, difference, the minus symbol. Okay. Let's see the intersection method. Yeah, use the ampersand. Yeah. Common elements. See, that's what we referred here, right? A intersection B. Elements that are common to both of the set or sets, right? Both sets. S1, we know what we have. S2, we know what we have. So S1 intersection S2 or S2 intersection S1, both will be same. Yeah, common elements basically. Whether you look at it from this angle or from that way, I mean, it's going to be the same. So S1 dot intersect of S2. Okay, intersection. So please be careful. Intersect? No, intersection. Right? Yeah. So S2 dot intersection of S1. So we are good with the symbols as well as these methods. Let's see, there are a couple of variations with difference and intersection. Yeah, difference update is one you have, and intersection update is one you have, right? Yeah, what is that? Let's understand. You want to find the difference as well as update. You want to find the intersection and update. That's what is the update extension of either intersection or difference. Yeah, we'll talk about symmetric difference in a while. Yeah, first let's see difference update. Okay, or fine, let's go ahead with intersection update. Okay, what is S1? What is S2 containing? So S1 dot intersection of S2 or S2 dot intersection S1, you will get 4 and 5. But here we are calling the intersection function or method using S1 object. So which object you are calling the intersection update method with, that object gets updated. Updated means the contents of S1 which are initially, yeah, look at that. The initial contents of S1 which are 1, 2, 3, 4, 5 will now be replaced with this common elements between S1 and S2. Why? Because you're calling this intersection update with S1 object. So S1 which was earlier containing 1, 2, 3, 4, 5, after we execute this code, it will have 4, 5. It will not contain 1, 2, 3, 4, 5. Yeah, but S2 remains unaltered. If in case we would have called S2 dot intersection update S1. Yeah, S2, which was containing 4, 5, 6, 7, would have been replaced with common elements between S1 S2. S1 would have been unaltered. Clear? Simple. Okay, let me get that two sets back again because I just want to work with difference update as well. So I'll just scroll a bit up and get that content of S1 S2, whatever I have initialized initially. I just want to get that, those two set elements. I'm just trying to work with numbers. You can take any type of element or any type of values and you can work. Okay, just trying to reinitialize. Okay, we know that S1 minus S2 and S2 difference S1 is not same, correct? So we know this S1 minus S2 and S2 dot difference of S1, they're not same, they're not equal. Okay, in the same way, S1 dot difference underscore update of S2, what will happen? We are calling difference update with respect to S1. So S1, the container object that is a set now, will be updated with unique elements that are there in S1 when compared to S2. So what are the unique elements in S1 when compared to S2? 1, 2, 3. So S1, which was earlier containing 1, 2, 3, 4, 5, will contain only 1, 2, 3. S2 remains unaltered. That is the difference between just difference, difference update, just intersection and intersection update. I hope you got that. Let's see what is symmetric difference. Okay, let's go to the diagram here. Symmetric difference is nothing but union of both the set differences, means excluding those common elements. Yeah, it is something like A minus B union B minus A. Means we want to exclude those common elements. That's what is symmetric difference. Yeah, symmetrically, what are the elements which are not identical in both the sets? You want to combine that. Okay, right. Okay, just because I have overwritten the contents of S1 there with difference update, I intend to recreate those two sets. Yeah, S2. Yeah, S1. We know what are the contents. Yeah, let's see that difference and use the symmetric difference. Yeah, symmetric difference, symmetric underscore difference. And the symbol being used there is caret. Okay, right. So whichever way you go, S1 dot symmetric difference of S2 or S2 dot symmetric difference of S1, it will give the same result. Let's see that. So first, let's apply S1 minus S2 and S2 dot difference. Yeah, difference, right? S1, correct? Yeah. So symmetric difference is going to get the union of S1 minus S2 and S2 minus S1. So we should have, see, S1 is containing 1, 2, 3, 4, 5 and S2 is containing 4, 5, 6, 7, 10, right? So let's see. S1 dot symmetric underscore difference, symmetric difference of S2 or S2, S1, both will be 1, 2, 3, 6, 7, 10. I'll show you S2, that symbol S1. It will be same. Yeah, whether you use that particular method, symmetric difference, yeah, symmetric underscore difference, or S2 caret S1, it's same. It's something like A intersection B and B intersection A are both same, but A minus B and B minus A are not same. Okay, so A minus B union B minus A or B minus A union A minus B is same. Set notation. So what is symmetric difference? Yeah, just for our purpose, our understanding. just try to expand that. A minus B. Okay, uppercase. Okay, no problem. Union B minus A. Or B minus A union A minus B. Yeah, both will be same. Like A intersection B and B intersection C are, sorry, A intersection B and B intersection A are same, right? Equal. Same way. Yeah, we are just trying to work with two sets here. Yeah, we can go ahead and work with 3, 4, more than, or any number. That's fine. Okay. Yeah. So if in case you have three sets, symmetric difference, A minus B union B minus A union C minus A or A minus C. Anyway, it's same, right? Yeah. Okay, let me just include that. Yeah, if you're a little bit curious, you can go ahead and you can work on that. There's no restriction in that, right? Yeah. Let's take that set C. I leave it to you to explore, experiment, and just get those required answers, right? Okay, that's fine. Yeah, there's a small change in there. Yeah, that's A intersection B intersection C. Correct? Yeah, this area. A intersection B intersection C. So what is this area? Okay, which area am I trying to refer to? Got to clear, right? Yeah. What is that? Yeah, just check what is that.
A intersection C.
Correct. But A intersection C includes A intersection B intersection C also.
Yeah.
So it should exclude that. So that area is A intersection B intersection C minus A intersection C. If you say it is A intersection C, it will include that A intersection B intersection C also. Please be careful. Okay, not a problem. That's no big deal. Just try to work on set theory one more time. If you have some idea on that set notation, set theory and all that, that is symmetric difference. Now symmetric difference update. Let's get back that two sets. Yeah, symmetric difference we have understood. Symmetric difference update. So S1, okay, let me use a symbol, is easy. Yeah, if you want to update any one of the two sets, S1 or S2 with that difference or symmetric difference, yeah, use that symmetric difference update. So S1 dot symmetric difference update of S2. So S1 contents will be changed with 1, 2, 3, 6, 7, 10. Earlier it was containing 1, 2, 3, 4, 5. Correct? Yeah, now, yeah, S2 remains unaltered. If you want to apply S2 dot symmetric difference update of S1, S2 gets altered. S1 remains unaltered. Okay, right. So it's all good. All functions are clear with all those operations, operators, the symbols. Yeah, remember union pipe? Difference is minus, intersection is ampersand. Yeah, the symbol for symmetric difference is that caret. Yeah, shift 6 on your keyboard. Okay. Yeah, how do we find whether two sets are disjoint? Yeah, this is disjoint is subset will return a Boolean value. So when do we say two sets are disjoint? When they don't have even one element common, correct? Okay. If they have at least one element common, we don't call them as disjoint sets. Right. Set theory, correct. Yeah, S1 dot, yeah, S2 dot is disjoint of S1, or S2 dot, or S1 dot is disjoint of S2. Anyway, if there is no element common, it will return true, otherwise it will return false. Okay, let's make a small change, small difference in there. Yeah, 4 and 5 are common, right? Let me remove those two. Okay, let me work with S1 dot is disjoint only. Now it is true. So when do we say two sets are disjoint? When we don't have any elements common between two sets. Okay, yeah, that's one point there. Okay, when do we say one set is the subset of the other? See, when all elements in one set are part of another set, then we say, okay, this set is subset of the other set. Obviously, the other set is going to be superset, right? Yeah. So in this case, S1, we can say, yeah, it is subset of S2. So S1 dot is subset of S2. True. Every element in S1 must be there. We cannot call this S1 is subset of S2. Why? Because it is containing three elements, 1, 2, 3, which are not part of S2. And the previous scenario, what I have discussed, with 4 and 5 elements only, where every element is there, which is there in S1 and S2, we can only say S1 dot is subset of S2, but not the other way around. S2 is superset. So how do you say S2 is a subset of S1? No, that's not correct. Subset means a smaller set. Yeah, when both sets are containing equal number of elements, then that's a different ball game altogether. See, yeah, if it is this kind, yeah, you can say S1 dot is subset of S2, S2 dot is subset of S1. I mean, one set is a subset of the other. I mean, both sets are same, basically. Right. Let's see sorted. Yeah, if you want to sort the elements, sorted. Okay, what we need to give? Yeah, we need to give the trouble object, that's the set. Let's see what it's going to return. By default, reverse is false, means you will get elements in ascending order. Okay. Set intensity taking different elements. Okay. Okay, I have 1, 2, 3. Okay, I don't have 3, right? Yeah, 3, 4, 5. Yeah, -1, -3. Yeah, let's have 0 as well. You might say already this is sorted. This is sorted. Okay, that's fine. Let's see. Sorted of S. That's a set. This is a list. List elements order is being maintained. Okay. So what you can do, okay, you want to just check this. Sorted of S. The type of it. Yeah, just look at the type of it. It's a list that is returning. List, remember, order is preserved. We can access the elements using index values. Yeah, sorted of S. First element, last element. Anyways, fine. We know all these tricks, right? Yeah, we are good. You want to sort the elements in descending order. Okay, this is S. Basically, reverse is false. You want to make it true. Descending order. Okay. So you know the clear difference between what is a set now, what is different methods that are available. We can add, we can remove, we can copy, we can perform some set operations. Okay. Yeah. I try to stop here. I hope we were good in analyzing the complete set container object. Yeah, we have seen all of them. How do we create a basic simple set? That's an empty set. Yeah, set containing elements that are repeating, which doesn't store, it stores only unique elements. So heterogeneous, you can store repeating elements of dissimilar data type. Okay. Then we have seen how case sensitivity is preserved, how it will consider each one to be a different one and try to store in there. And then we have discussed how 1 and true are same and 0 and false are same as part of Python. Then we have seen how do we add elements, remove elements using remove, discard, and pop. Then we have seen the copying options of shallow copy and deep copy using that particular copy method or copy function. Then we have seen the set theory related methods. Union, intersection, difference. Yeah, union update is not there, right? Basically. Yeah, intersection update and difference update. Then we have seen symmetric difference, then symmetric difference update. Then we have seen what do you say or when do you say two sets are disjoint, or when do we say one set is subset of the other. Okay. Then we've seen how we sort the elements in a set. Default order of arrangement is ascending. So I think we are good. I'll try to stop here. I'll take questions if in case you have any. Otherwise, we are done for today. All right. Thank you.
Thank you, Gopal.